Hey everyone, welcome to Sequence of Instructions. Thanks for joining me. In this video we're going to learn a searching algorithm called binary search. Binary search is a really efficient way to quickly check a list for whether or not a given element is in it. The only caveat being the list given, the array, must be sorted. So if you have a sorted array, for example, let's say I have these numbers here, 1 through 11, they're in order, they're sorted. I can now use binary search. Let's think about the easiest way to check if an element exists. Let's say I said, alright, does the number 4 exist? Well, if you did it the easy way, you just check each element. You'd say, alright, is this a 4? No. Is this a 4? No. Is this a 4? No. Etc., 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 until you've either checked every element or you found a 4. But that could take some time if your array is 1,000 or 10,000 or a million elements long. Computers might choke on that. So a better way to do it, given the fact that it's sorted, is to use binary search. And I'll give you an example of how it works. Again, let's say I'm looking for this 4 here. I'm going to check an element in the middle of the entire array. So I'm going to say, alright, between the first element and the last element, pick one right in the middle. In this case, it's going to be 6. I'm going to say, is 6 greater than or less than the number I'm looking for? In this case, I'm looking for a 4, so 6 is greater than. I'm going to then ignore all those numbers that come after 6, including 6. I'm going to search again. Alright, say, okay, given this new array, I'm looking for a 4. I'm going to pick the element right in the middle. In this case, it's a 3. Is the element I'm looking for just 4? Is that greater than or less than 3? It's greater than 3. So again, I'm going to ignore all the elements that come before my 3, including the 3. I'm going to search again. And so you can kind of see how every time I do my check, pick my middle element and check, I'm cutting the length of the array I need to search in half. And that's where the term binary comes from, by origin of bi being 2. Every time I do this check, I cut it in half. Which means even if our array, so if you have an array of length 1, you can determine what element, whether or not it exists in basically 0 checks. You just check. If your array has 2, you'll have to check at least once. Do this check, this binary search, at least once. If it's 4, you can do it in 2. If it's 8, you can do it in 3. And what you're kind of seeing here is the number of checks it takes. So if you have 16 and if you have an array that's 16 elements long, you can be certain whether or not the element exists in 4 checks. So it's always a factor of 2 to the the number of iterations is the log of n, where n is the number of elements in the array. So if you had 32, it would be 8, or it would be 5. 64 would be 6. 128 would be 7, right? 256. So an array 256 characters long, going one element at a time would take 256 iterations. Binary search does it in 8. That's how efficient this searching algorithm is. So let's get into it. How does it work? Let's write it out. Here's my binary search function. It's going to take an array and some value I'm trying to find. Alright, and so if the value exists in this array, I'll return true, and if this value does not exist in this array, I'll return false. Alright, and so in the example I gave you before, the 4, which is the element we were looking for, did exist. But you can imagine, even if it didn't exist, at a certain point, we would be dividing it in half, constantly dividing it in half, until we'd realize, oh no, it doesn't exist, like we're already past it, there's nothing less than, in which case you'd return false. So the principle is the same, there's just an extra check you have to do. But let's get into it. The way it works, we're going to have a min index, which is going to start at the very first element. We're going to have a max index, which is going to start at the very last element, -1. So array.length being the number of elements, subtracting 1 being the reference to the last element. And then we're going to have some var current index that we're going to always pick to be the middle of these two. Alright, and the way it works is, as long as our min index is less than or equal to our max index, which basically, I'll explain in a second, but this is basically saying as long as the array we're checking for has at least one element, we're going to do this. We're going to check. We're going to get the current index. It's going to be rounded down max index minus min index. All of this over 2. Make this a little bit bigger. So this is saying In the first step, it's the full length of the array. My min index is 0. My max index is this last element. I basically add their differences, or I take their difference and divide by 2. So I find the average of them. So the average of the first and the last element is going to be the middle element. As we drop this array, we're not actually deleting the elements, otherwise this could stay. What we're doing is we're just going to ignore them by moving our min index up. So we move our min index up to the 7th position. The new average of this is going to be 9. Alright? And we round it down in case we have an odd number, or I'm sorry, an even number. So if this was our array, 0 plus 3, I'm sorry, 3 minus 0, what am I doing? This is supposed to be a plus. 0 plus 3 is 3, divided by 2 is 1.5. 1.5 is not an element, or I'm sorry, not an index. It doesn't reference any element in this array, so we need to round it down. Alright, so we get our current index, and now we just check. Is the element at that index, is it greater than our target? Alright, so again, whoops, I removed my array. But let's say here's my array, I'm looking for a 3, I pick a 2. Or rather, I'm looking for a 2, I pick a 3. If it's greater than, I'm going to move my, I want to get rid of the elements that are larger than it. If I'm already larger than my target, I want to get rid of that element and everyone that comes afterwards. So I'm going to move my max index down to my current index minus 1. We say minus 1 because we don't want to include the one we just checked. Alright, the opposite is the same thing but greater than. So if my element is greater than, or the element I'm currently on is greater than my target, I want to move my min index up. Oh, I did this back. Is less than my target. Excuse me. I want to move my min index up. Okay, in the other case, they are the same. So if it's not greater than, it's not less than, they must be equal. We just return true. We go, yep, your element does exist. If we exit this loop, basically we'll exit this loop if we've checked the entire array and we never return true. So by default, if we ever exit the loop, we're going to return false. So if at any point in cutting our array in half and checking, and cutting our array in half and checking, we find that it is equal to it, which would be counted for in this else, we return true. We don't have to do any more checks. If we do all these, cut in half, cut in half, cut in half, cut in half, and we never return true, we must return false, because we must therefore know that it's not in there. Let's see if this works. Here will be my array. Do this through 11 again. And we will console.log, excuse me, array, let's look for 6. Is 6 in there? Whoops, what am I doing? Console.log, binary search, array in 6. 6 is in there. Is 8 in there? 8 is in there. Is 12 in there? It's not. So you see this works. If we get rid of a 5, and then search for 5, it's not in there. So this is extremely powerful, extremely common too. A lot of sorting algorithms or searching algorithms, I think, use this. And it's a good one to know because you may use principles of it in your day-to-day coding. Alright, hope you got some out of this video. If you have any questions, feel free to leave them in the comments. Till next time, take care. Bye.